So for this problem, the first thing that you notice is that if you've got a radial line coming out from the origin like this, the distance that it goes is going to depend on the angle, right? So the upper bound for the radius is not going to be a constant. The lower bound for the radius is going to be equal to 1, no matter what direction we're going in. But the upper bound is going to be given by this line here, unless we get past this angle, in which case it's going to be given by this line right here. Okay, so we're going to have to split this into two regions of integration, right? So now looking at the lengths here, we have that this is a triangle with a side length of 2 and 2 root 3. So that means that this angle has to be pi over 6 and this angle has to be pi over 3. So that tells us, let's see, for our first one, so I'll do the pi over 6 one first. So we're going to be going from 0 to pi over 6. And then in order to figure out what our radius is going to be, this radial line, this comes out here. This line that I'm ending on right here, so my upper bound of integration, is the one given by, whoops, there we go, x equals 2 root 3. So in polar, that's r cosine theta equals 2 root 3, or r equals 2 root 3 secant theta. So that's going to be our upper bound, 2 root 3 secant theta. And then our lower bound, we begin when we first hit this arc right here, which is the line where we have r equals 1. So we're going to go from 1 upwards, okay? And then we've got some integrand, and that's going to be dr d theta, I guess r dr d theta with some integrand. And then the other one is now going to be for this latter part here. So for this one, we already start at pi over 6, and we go the other pi thirds of the way until we get to pi over 2. And here we're going to begin at 1, just like we did before, but now we're going to end on this line right here, which actually, let me make it orange so everything's a different color. This line right here, so this is the line y equals 2, or r sine theta equals 2, or r equals 2 cosecant theta. And then the rest is as before. All right, so there's the first one. For the second one, let's see what we got. So again, we do some messing around with geometry, and so this radius right here is apparently equal to 2 because of this indicator right here. So this intersects at 2 and minus 2, etc. And in particular, if you focus your eyes on this triangle right here, you can see that this has a hypotenuse which is twice the length of its base. So this has to be pi over 3 right here. So that means that we are going to be going from an angle down this way of, oh come on, an angle down this way of minus pi over 3 up through sweeping out this arc up here to where theta equals positive pi over 3. So we're going to do that integration. So that'll be this one. And then for a radial line that's coming out through here, you can see that the interior starting point is going to be given by this vertical line right here, and then it's going to keep going until it hits this circle around the outside here. So the easy part is the circle at the outside. That's where r is equal to 2. Now for the vertical line here, this vertical line is the line x equals 1. So again, that's r cosine theta equals 1, or r equals secant theta. So we've got r going from secant theta to 2, r dr d theta.